Rivera here from the Oxford.
Recording in progress.
Well, good morning, everyone.
Good morning.
Edgardo, good morning.
Good morning, Brad. Good morning, everybody. Are you, Brad, are you recording this meeting or taking the assistance or to have for the record all the assistance?
Yes, first request is that everybody on the call put your microphones on mute, please. Thank you. So Edgardo, I think I heard your question if we were recording this or another question, but we would like to record it. If that's not recommended, let us know.
It's just, I was asking if you are recording or you are taking the assistant for having for the record all the assistants for in this meeting.
Yes, I'm not sure what you mean by assistance, but we are recording it.
Okay. Like an assistant list, you know, who attend.
Oh, attendance list.
Yeah.
Okay, we will provide the attendance list, Edgardo, after the meeting.
Okay, thanks.
So to respect everyone's time today, we'd like to get started, if that's okay. Edgardo, do you have any opening comments or notes?
No, not from me, just maybe we can make a little introduction of ourselves. And my name is Edgardo Contreras. I am the director on the engineering office of the Puerto Rico Energy Bureau. Good morning, everybody. And with us is Belerity and is Brad, I believe is Rick. So you can proceed to present yourself.
Excellent. My name is Brad Bradshaw. I'm leading the Valerity team on this initiative for the Energy Bureau. First, I appreciate everyone's time and contribution to this project and your time today. The approach we're taking is to have it be interactive. So we seek input at every point along this engagement. It's a collaborative effort. With me is Jorge Rodriguez, Rick Smith, and Kathleen McKenna. If you could each just briefly introduce yourselves. Rick.
Hi, my name is Rick Smith. I founded the Hydrogen Energy Center in 1991. So I've been looking at these issues for a very long time and hope to help you make some progress here.
Thank you, Rick. Jorge.
Yeah, my name is Jorge Rodriguez. I'm part of the Valerity team. Most of you guys know me. I've been around for 40-something years, both in a point in time in the government working for managing PRAS and PREPA, and then consulting on the energy and microgrid space for the last 20 years. So glad to have you all here.
And Kathleen.
Good morning. This is Kathleen McKenna. My background's in mechanical engineering. I worked with Valerity last year on the study and again on the implementation plan. Thank you all for being here.
Appreciate that. And Edgardo, do you have an interest in us going around the room? The other participants?
No, it's just me.
Okay, great. Great. I meant certainly should we have everyone in the room in the on the Zoom call introduce themselves, but I think we should get moving at this point. So today's agenda is to provide background information on the hydrogen study that was completed in 2023 and provide an introduction to the hydrogen implementation plan project, which is currently underway. First, I'd like to express appreciation for the Oversight Committee for the current hydrogen implementation plan project. Been an excellent contribution by this committee, very important part of getting this project moving in Puerto Rico, and getting input from stakeholders is an absolutely critical part of this project, and the Oversight Committee has been very helpful in that regard, as well as providing input on the project content as well. The reason we're here today began in 2022 with the signing of an executive order for the purpose of recognizing hydrogen as a potential source of renewable energy in Puerto Rico. And the first question that needed to be answered was, what is the practical opportunity for Puerto Rico, and what's the opportunity that is specific to meet the needs and requirements of Puerto Rico's energy system going forward. And so a study was initiated in the summer of 2022. We refer to it as the hydrogen study, and that hydrogen study resulted in 7 potential hydrogen initiatives for Puerto Rico. And the primary purpose of today is to review those hydrogen initiatives, as well as introducing the working group process that we're pursuing as part of this project. We went through a process in the hydrogen study to identify potential initiatives and to characterize those potential initiatives for hydrogen. And I want to make a clear point here is that we did a high-level characterization of a large number of potential applications, but we also performed economic analyses of a select set of initiatives as well, with one of the criteria being that these potential initiatives had to make not just technical sense for Puerto Rico in terms of addressing issues of resilience and reliability and power cost, but also had to make sense from an economic and market perspective as well. And that's always been part of this assessment, and it's made it quite a unique assessment in terms of what we're doing for Puerto Rico. It also began with a fairly detailed assessment of the situation in Puerto Rico from not just the storms and the impact on the power system, but also the economics, the imports, various factors with regards to the needs and interests of the people of Puerto Rico, in order to understand what is it that these initiatives can do to contribute to the needs and aspirations of the people of Puerto Rico going forward. Very, very brief on hydrogen. Hydrogen has caught the attention of companies and governments around the world. This forecast from 2021 to 2050 shows a near tripling of demand for hydrogen as a key part of a decarbonization across the globe in all sectors of the economy. This is just an extraordinary growth in terms of hydrogen. You can see this growth represents going from nearly 100 million tons per year to 300 million tons per year in production and demand. And we can also see sectoral changes in demand. The blue at the bottom, for example, is petroleum refining, which is one of the dominant uses of hydrogen today. Ammonia is a major use of hydrogen, and we can see the ammonia nearly tripling in terms of ammonia produced from hydrogen. And then we see additional new applications going forward, including transportation and fuel use, hydrogen as a fuel use. So the question is this real? Is this practical? And why is this tremendous growth potentially taking place in hydrogen? One of the key factors in green hydrogen, in hydrogen that's produced on a low carbon basis, just to step back for a second, most hydrogen in the world is produced from steam methane reformation. Natural gas is converted into hydrogen using high pressure, high temperature, and catalysts. And that's the dominant way that hydrogen is produced today. And it's responsible for a fair amount of CO2 emissions. So this transition, this growth in new hydrogen, it's not based on expanding steam methane reformation or fossil fuel-based hydrogen production. It's based on the economic viability of producing zero carbon hydrogen from water splitting. And this takes place using renewable energy that feeds an electrolyzer and splits water into hydrogen and oxygen. And this process is really only predicated on this extraordinary change that has taken place across the globe, which is the vast reduction in prices of wind energy and solar energy. And that enables hydrogen to be a more compelling source of energy from an economic perspective. And we can see these charts just represent power purchase agreement prices for utility scale solar on the left and wind energy on the right. And this is really the key enabling factor that allows us to even consider hydrogen, clean hydrogen, as part of a decarbonized future. This chart is very complicated, but it shows a value chain for hydrogen from feedstock on the left to end use on the right. And there are many sources of hydrogen. Fossil today is the primary source, but you can also get hydrogen from what are termed biogenic sources, such as landfills, agricultural waste. You can also get hydrogen from wind, solar, hydroelectric, as well as the ocean thermal energy conversion opportunity that exists in Puerto Rico. And certainly there are proponents of nuclear hydrogen, which certainly does not apply in Puerto Rico, but is being pursued elsewhere in the world. The different production technologies, and then there are conversions. Conversions basically mean that hydrogen is used to produce ammonia, it's used to produce methanol, and a lot of use of hydrogen. Hydrogen is consumed in the same place that it's produced because it's very difficult to move hydrogen. This is one of the great challenges that are being addressed around the world, which is how do we get hydrogen from point A to point B cost effectively? It's very expensive to move as a gas because its density is very low. The second option is to move hydrogen in liquid form, and this is being done around the world. The transportation industry is pursuing liquid hydrogen as the means of transport and distribution. There is a cost. It takes about 30% of the energy in hydrogen to produce liquid hydrogen. So there is a cost that's involved. But the other approach is to turn hydrogen. Yes, I appreciate it if everybody on the call could mute their microphones. Thank you. So there is the conversion of hydrogen into other forms, including methane, ammonia, as well as kerosene, which is essentially sustainable aviation fuel, and turning it into other sort of chemical feedstocks. And that's ammonia, for example.
I lost weight
We mentioned significant growth in ammonia, and that's due to the ease of transporting ammonia around the world in ships, and it seems to be a fairly cost-effective way to move hydrogen. And ammonia can also be used in power generation. It also can be reconstituted to form hydrogen at point of use as well.
That's alcohol if you're going to drink.
Just like skinny jeans, these are the new pants to wear.
I believe Wanda Stera has the microphone open. Will you please mute her? Thank you.
We did a fair amount of work on the details associated with Puerto Rico challenges and circumstance. It's absolutely critical that any solutions be designed specifically for the circumstances in Puerto Rico. This is a very brief list of some of the considerations, and certainly we prioritized a few key ones, which is resilience and reliability, enabling a more distributed, resilient power system, contributing to lower the cost of power in Puerto Rico, also addressing the opportunity potentially to expand the economic activity within Puerto Rico and to potentially generate export revenues for the country as well. And we will talk about that going forward. And we also specifically wanted to use hydrogen initiatives to expand the capacity for Puerto Rico to increase renewable energy and reduce carbon intensity. And this is a somewhat of a restatement, but the key here is that there is a potential for Puerto Rico to produce hydrogen from renewable sources, we'll say on the island, but really the dominant opportunity is offshore wind to hydrogen, and actually, reduce the imports of energy and actually generate export revenues potentially as well. So we have initiatives that produce ammonia. We have an initiative that looks at the production of aviation fuel on the island, and it could also be exported to the Caribbean region. And we have initiatives that address resilience and reliability with backup power and microgrids. These are just some of the initiatives we'll talk about in a minute. One of the calculations we did to assess the opportunity for Puerto Rico is to determine how much hydrogen could be produced on the island from different sources. We do recognize we did not include the ocean thermal energy conversion. We have that calculation. It's just not on this slide. But this is somewhat of a way to take an inventory, as it were, to see what could be accomplished. We did a calculation on solar, and one of the issues here is if we look at solar in places like California and in Germany, where there's a high penetration, we're seeing negative prices on the grid because of the overproduction of renewable energy. We also see increasing proportion of curtailment in those locations when the solar and the wind has to be turned off because the grid is not able to accept it, overproduction situation. And we envision this occurring at some point in Puerto Rico as well. And that curtailed solar and curtailed wind can be used to produce hydrogen. Put those electrons to work. There are also the opportunity to produce hydrogen from landfills in Puerto Rico, also from wastewater treatment plants and agricultural waste. Now, I do want to point out that as we could say, the elephant in the room, if we look at wind, there are two categories of wind that were in this initial calculation. The first is the 3.2 gigawatts of wind with 20% curtailment. And I think this is off an NREL study that looked at the onshore wind potential in Puerto Rico, and we used a 20% curtailment number. And if that curtailed electricity was turned into hydrogen, it would produce 44,000 tons per year of hydrogen. For a offshore wind, 40 gigawatts dedicated wind, that number is very large, and it's just an extreme number essentially. But the potential there is for 2.7 million tons of hydrogen per year, and that, as can be said, is the elephant in the room. Puerto Rico has a very significant opportunity to develop offshore wind and turn that offshore wind into hydrogen. And it's also, we'll talk about it, there are wind sites off the southern shore of Puerto Rico, including both fixed and floating wind turbines that have a fairly favorable capacity factor and wind profile. We investigated that wind resource, and we also considered the ocean surface set-asides where wind turbines could not be deployed. And we have these calculations further down in the study. Certainly no need to go to 40 gigawatts of wind, but we wanted to point out the massive potential. As I've said, in our process, we investigated a number of different applications. We rated them based on various criteria for Puerto Rico, and we identified 7 potential hydrogen initiatives that merited further assessment, and that's what the current implementation plan is focused on, which is how do we further refine these opportunities and identify the likelihood of success from regulatory, permitting, economic, market, and technology perspectives going forward for Puerto Rico. So we will review each of these: backup power using hydrogen, hydrogen for microgrids, hydrogen in the transportation sector, long duration storage with hydrogen, ammonia production with offshore wind, and then producing hydrogen for sustainable aviation fuel, and then power generation with hydrogen has some assessment in this project as well. So we'll start. This is very because of we have lots of detail on these initiatives, but today we're just going to try to do our best to explain, help describe what it is we arrived at and what some of the options are. So this is being pursued around the world. Backup power for critical facilities. There are probably, for example, 60,000 cell towers around the world that use hydrogen for backup power. And why is that? The hydrogen actually can be a delivered fuel that lasts a long time, and it's cleaner, more efficient than diesel. And it also is more robust from a technology perspective, and then can also much better than batteries because it can provide much longer duration, and that's really the key. You complement it with batteries, but it really extends the ability to provide clean power over a period of time. So there are two basic solutions. One is a enclosed on-site hydrogen production solution where solar energy is producing electricity at a local facility. That solar energy can be stored in a battery for 8 hours of backup power, but then there's the opportunity to produce and store hydrogen and then use that hydrogen and have, for example, 120 hours of storage with hydrogen. There are a number of different technologies that can be used for that. The key is the storage medium. One of the winners in this distributed smaller scale backup power solution is called metal hydride storage, where hydrogen is stored in tanks of a material that essentially absorbs the hydrogen. Then it can be released to regenerate electricity as needed. And there are companies that provide packaged solutions that basically encompass the three elements shown in this chart: the electrolyzer, the hydrogen storage, and the fuel cell. The other solution for larger facilities for backup power using hydrogen is to have a delivered hydrogen solution coupled with a fuel cell. And again, these can be very clean hydrogen solution and can provide 3 to 5 days of storage depending on the need. And this would be for critical facilities and importantly, water and sewer, telecommunications, etc. So emergency centers on the island. And this can be, the beauty of the on-site hydrogen production, storage, and then power generation is that does not require delivery infrastructure. It's wholly encapsulated in a distributed solution. So these are some of the technologies that are being deployed around the world and might be of interest to Puerto Rico. And again, there are critical facilities that can be identified and prioritized for these types of technologies. And it's not to say batteries are not good. It's necessary to have batteries, but the hydrogen provides a longer duration solution. The second major initiative we're looking at is microgrids. And microgrids vary in size. And so depending on the size of the microgrid, will determine the type of technology that's deployed. Again, the small microgrids can use on-site hydrogen production, storage, and power generation, similar to the backup power. But this is designed so that the solar plus batteries are enhanced with a hydrogen solution that enables, the ability for the microgrid to operate independently of the grid, and that's the enabling solution that hydrogen can provide. And in almost every case we've seen in different parts of the world, the hydrogen replaces diesel gen sets that are typically used. Also, there is the use of solid oxide fuel cells that run on natural gas, but that still emits carbon. So hydrogen provides a clean, distributed solution to complement solar plus batteries in the case of Puerto Rico. The other types of microgrids really relates to medium size and then very large microgrids. And these are based on a delivered hydrogen model. And there are two versions of delivered hydrogen. One is the straight delivered hydrogen in the middle, which you can see is a tube trailer. And there also, for example, can be deliveries of liquid hydrogen with the liquid hydrogen stored on site. A few of those projects are going forward. And that's similar to a delivered fuel solution, but it's a clean fuel that can be produced in Puerto Rico. And then on the large microgrids, companies have developed ammonia turbines for power generation, and this would be green ammonia. So not to confuse the circumstance, but the ammonia is produced from hydrogen and nitrogen that's captured from the air, and that hydrogen would be green, so the ammonia would be referred to as green ammonia. And it's important to note that ammonia does not have any carbon in its molecular structure at all. So it is a very clean fuel source as long as the economics work. So ammonia is being pursued as a power generation. In fact, some of the largest ammonia purchase agreements that are being executed, Japan, for example, is already purchased 1.5 million tons per year of green ammonia from the United States. There might be some blue ammonia mixed into that, those purchase agreements. But the ammonia is used for power generation in Japan. The transportation initiative, I think it's important to include transportation. I just want to make it absolutely clear, however, that the dominant transportation use of hydrogen today is for large trucks, heavy vehicles. And these vehicles benefit from hydrogen because of the distance they travel, and it's very hard. This is considered very difficult for electrification. And to be clear, electrification is a very important part of every strategy, but there are limits to the technical and operating implications of electrification of large trucks, for example. But here's the thing. Puerto Rico does not really have a long distance trucking market. And so just large trucks traveling on the highways in Puerto Rico is not necessarily a priority application. It really is more to what we identified in terms of targeting in the box on the right. Drayage trucks in the ports are basically the trucks which take containers out of the ports to distribution centers. And then an important market is municipal fleets, including dump trucks, garbage trucks, intercity buses, municipal buses, for example. And those applications, we can actually see a little uptake. Yes, buses can be electric, but we're seeing some constraints. And so we're seeing bus systems, for example, have both electric buses as well as hydrogen buses because it facilitates longer routes with hills that are more challenging from an electric perspective, et cetera. And then ultimately, there also can be constraints on the ability to have the power required to refuel electric vehicles. There can be some constraints on the grid, and that might steer some towards a hydrogen solution to complement the electric solution as well.
Excuse me. How much is the distance that you mentioned that is this long distance for trucking?
Yes, say that again.
You say that no longer distance for trucking, but what is the what you mean? What is the in terms of distance, the number?
Oh,
100 miles, 100
500 to 600 miles. Yeah.
Okay, I'm agree.
Yep, exactly.
Perfect.
Thank you. So we did model the potential, but again, we think this has to be a more targeted solution around the potential for municipal vehicles and the drayage or the container transport trucks out of the ports as well. And the ports have the opportunity to have the lift machines run on hydrogen that sometimes can help alleviate some of the challenges with the electrical load associated with the heavy lifting capabilities. So another potential solution for Puerto Rico is long duration energy storage. Now, we did take a careful look at the NREL study, or we're referring to it that way, so the PR 100 study, excuse me. And they had two sort of surprising elements of their 2050 scenarios. But one element of their 2050 scenario was unspecified long duration storage. And the reason being is that batteries, the lithium-ion batteries, which dominate today, are very important. But the capital cost associated with having 3 to 5 day to multi-week energy storage using lithium-ion batteries is just not viable from a capital perspective and an economic perspective. So alternative solutions for long duration storage are being developed around the world, and hydrogen is one of those solutions. Now, for example, there's a very large underground hydrogen storage project underway in Delta, Utah, to store renewable energy in the form of hydrogen, and then to store that hydrogen in time of overproduction of renewable energy, and then to release the hydrogen when the grid needs the power and the renewable energy is not providing enough power. And so it's a what could be termed an arbitrage opportunity, and 30% of the time might be producing hydrogen, and then 30% of the time would be releasing that hydrogen to generate power. and that's being done in Delta, Utah for the San Diego Gas and Electric, the Los Angeles Department of Water and Power, and I think the San Diego Gas and Electric as well. The opportunity for Puerto Rico, however, most underground hydrogen storage is done in salt caverns. So the salt caverns are big deposits of salt. They spray in water over several years, and the water melts the salt, turns into a brine, and the brine is pumped out, and what's left are these big salt cavities underground that can store hydrogen satisfactorily and at pressure and at very large volume. But certainly Puerto Rico does not have any salt caverns. There are no salt caverns in Puerto Rico. So the next alternative is what is called lined rock caverns. This is an established underground storage approach. There is a underground lined rock cavern storage system being built in Europe, and it's been used for other other gases. And so it is an established approach. It's slightly more expensive than the salt caverns, but it is not prohibitively, just to be clear, it's not prohibitively expensive by any means. In fact, we have run the numbers. And so we would suggest in this particular circumstance to have 2 underground lined rock caverns. This is where the caverns are dug underground and then lined with steel, and then can store hydrogen. And we are suggesting 2 underground caverns in Puerto Rico to store a total of I think we calculated 1,000 tons of hydrogen that can be used for long duration energy storage to be able to take up overproduction of renewable energy and then release it onto the grid to both from an economic and a clean carbon perspective. Small footnote on this slide is there are 200 lined rock caverns around the world that store a variety of materials. So this is an established technology. We modeled a illustrative day in 2030 in terms of solar. And again, this is a very high level kind of analysis, but we wanted to understand what the potential role of hydrogen long duration storage would be on the Puerto Rico grid. And so we modeled a very specific scenario to see what the implications would be. And then the whole idea being is there a limit to how much renewable energy can go on Puerto Rico's grid, and what is the role of long duration energy storage in releasing the opportunity for greater penetration of renewable energy on the grid. And absolutely critical is Puerto Rico has a very aggressive, appropriate and aggressive solar initiative, but there's the potential on the island, a truly islanded grid, that a certain portion of that power will be stranded, as there will be overproduction circumstances. And the question is, how can we economically use those stranded electrons? And hydrogen is one of the solutions that can be used in that case. And we put the summary of the numbers. We're not going to go over these numbers today, but I want to just provide, this is one example. We did detailed analysis on all of the initiatives, and to respect time, we're not going to go over all those numbers today. In this particular case, we did a model that did arbitrage on power for the long duration energy storage. It's a fairly large system. It's a 300 megawatt combined cycle turbine, a 550 megawatt electrolyzer, and we had an arbitrage pricing of 7-cent power purchase and 12-cent power sale price, and the economics were viable based on these analyses, which is certainly available. But again, we're not going to dig into all the detail today. Another very innovative solution for Puerto Rico, not innovative from a technical or risk perspective, but just in terms of a shift here, is we did a detailed analysis of the offshore wind potential. We do know that in the not the current integrated resource plan, but the previous integrated resource plan had a requirement or a request for doing additional wind resource assessment in Puerto Rico. We're interested in seeing if that assessment was performed. We have the analyses enclosed, which identifies areas for potential offshore wind. We characterized the wind resource and calculated the potential production from offshore wind. We have in this analysis 1 gigawatt of offshore wind, and it's a combination of fixed and floating technologies for the wind systems. And the chart in the upper right with the stepped blue, gray, yellow chevrons is a very interesting. The discussions with potential wind developers. We spoke with Ørsted, and then we spoke with another wind developer, and we said, well, what's the potential in Puerto Rico? Are you interested in Puerto Rico? And they were their basic concern was the Puerto Rico grid is not big enough to warrant a very large offshore wind farm. These offshore wind development projects take on average about 8 years. They're very large in scale. They're usually around 1 gigawatt or larger in terms of the scale. So these are massive projects, and the wind developers want to make sure that the grid is large enough to take the power to support the economic business cases that they have to make. And Puerto Rico's grid was not considered large enough to warrant, wind companies coming in and making a case for development. Now, the opportunity to produce ammonia, however, is a different story. Just in terms of another case, Trinidad and Tobago at times have supplied upwards of 15% of the ammonia used in the United States because they developed their natural gas resource to produce ammonia. They've developed a plan to deploy offshore wind to produce ammonia and to supply that ammonia to the United States. This same opportunity exists for Puerto Rico to actually generate and export product in the form of ammonia. So to take wind power, produce hydrogen, use that hydrogen to combine with nitrogen from the air to produce ammonia, and then export that ammonia to the Caribbean region as well as the United States, the lower 48, as well as potential for European and Japanese Asian markets for export. Now, the second opportunity is for Puerto Rico to take a portion of that electricity from the wind system and actually use that on the grid in Puerto Rico to contribute to the lower cost renewable energy opportunity that wind would provide. The hydrogen can also be turned into a product and used on the island. And then finally, the ammonia can be used on the island for fertilizer production as well to reduce fertilizer imports. So there's a series of ways that this system can be leveraged to Puerto Rico's advantage and allocating portions of the stepped products that are produced. We also estimate that if Puerto Rico has a system with 1 gigawatt of wind, it could produce 500,000 tons per year of ammonia, and this could generate $1 billion in export revenues for the island. So it has a particularly interesting economic consideration. We have additional information on the system, but we're going to just keep moving today. Another opportunity is that I think Puerto Rico consumes 400,000 tons per year of aviation fuel on the island. Excuse me, 180 million gallons of jet fuel per year. And that is, that costs money to import. It certainly is emissions driven. But the opportunity exists potentially for Puerto Rico to leverage off additional offshore wind to produce sustainable aviation fuel and to provide that fuel on the island and potentially an export product to the Caribbean region as well. Now, the final initiative that we looked at last year was the opportunity to produce power from hydrogen. And we scoped out 3 scenarios. So one scenario is to use hydrogen for power generation. And this is large scale. This is grid scale, 200 megawatt plants to 300 megawatt plants. You could also use ammonia produced on the island or imported for power generation. And then a final scenario is methane pyrolysis, where LNG is imported. The LNG is then run through a pyrolytic process, a very high temperature with a catalyst that then splits the natural gas into its components of hydrogen and carbon, and the carbon precipitates out. So you essentially reduce, I heard it recently said it's like a filter on the natural gas. You're filtering out carbon before it then turns into hydrogen and then can be used for power generation. So it's a way to take out solid carbon. It's there is an energy cost in the process, but it's not as challenging as trying to take CO2, carbon dioxide, and embed it underground or under the sea, et cetera. So it's a different process, and we ran the numbers. Fundamentally, there's no business case for using hydrogen directly in large scale power generation. It just logistically and economically is not viable. What we're seeing in power generation from clean hydrogen is the use of ammonia. As I mentioned earlier, that Japan's already issued contracts for 1.5 million tons per year of clean ammonia from the United States, for example. Germany is acquiring clean ammonia from wind plants in the Canadian Maritimes. It's seen as a more effective way to capture clean hydrogen, put ammonia in ships. There's currently, I think, 120 ships in the world that transport ammonia already around the world. And then you can use that ammonia for combustion. Then finally, the methane pyrolysis opportunity, and then the methane is converted into hydrogen, and the hydrogen is used for power generation. And there are turbines that are in the development cycle now that can use 100% hydrogen for power generation. So this is important. Yes, there are concerns about nitrogen oxide releases, and that's being addressed as well, but it's one of the solutions. And as I said, those are the three scenarios we modeled. And the economics, you can see the three scenarios: power plant, 200 megawatt, based on hydrogen, ammonia, and pyrolysis, methane pyrolysis. And we have a summary of the economic analysis that we performed last year, and the delivered hydrogen price, the delivered ammonia price, and the methane pyrolysis price of electricity. And it's not a typo because of various incentives. The methane pyrolysis price appears to be negative here, and that's because you actually can sell the carbon. You can actually generate benefits of up to $3 a kilogram for the hydrogen, and then you certainly sell the power as well. So there are three different sources of revenues when you're involved in a methane pyrolysis system. The hydrogen incentives will vary based on the carbon content. So I don't want to hold out that it's $3 a kilogram. It's going to be less, but that incentive exists as well. We were surprised by these results, but it warrants further inspection, and that's part of what we're doing this year. So, quick transition to what we're up to now in terms of the hydrogen implementation plan. So just a couple of slides, and then we'd like to open it up for any comments, discussion, or questions today. So the core purpose of the current project, which is to develop the hydrogen implementation plan, it also can be referred to as a hydrogen roadmap for Puerto Rico. And it really, the purpose here is to, what are the challenges and barriers associated with implementing the hydrogen initiatives we've just discussed? And what are the potential solutions that are needed to overcome these potential barriers and challenges? And then we also will be refining the hydrogen initiatives based on both analytical work as well as input from equipment providers, market participants, and regulators in Puerto Rico, et cetera. But this is very important to get feedback from stakeholders in Puerto Rico. This is a very important part of this project and initiative. As part is refining these initiatives and identifying those which should move forward. And the result, the implementation plan, stakeholder and public participation, engaged market participants, and certainly recommendations on any kind of policies and actions and market mechanisms that would be required in order to move forward. And then finally, the development of some kind of infrastructure relative to monitoring and providing oversight of the implementation process to track it and help move it forward as we go forward. This is the creation of an ongoing process in Puerto Rico to move the most valuable initiatives forward, each in their own time. The approach to the project, governance and oversight, we formed the oversight committee early on as part of the project. We are now been forming working groups, which are absolutely critical part of this process, very important. And these working groups are going to be integral to identifying the barriers and challenges, refining the potential initiatives, and also brainstorming and identifying potential solutions, as mentioned, from a regulatory, market mechanism, financial, OEM type approach, as we go forward. Very, very critical. And we have a task plan, and our team is providing analytical support as we go forward on this initiative. I know this is too much detail, but we do have a detailed project plan that we're following as we go forward. And we're just about to implement the working group process in 2 weeks. Tuesday, the 9th of July, as I recall, is the first working group meeting. And that's we're laser focused on that process right now. Again, to restate, the purpose of the working groups is to help inform and refine the hydrogen initiatives, to identify potential barriers and challenges in each of these initiatives in their implementation phase in Puerto Rico, and then to identify, if they exist, potential solutions that could be considered as we go forward, and help to shape and influence the recommendations and implementation plan from this initiative. Because the number of initiatives is at 7 is fairly large, we've broken the project into 3 separate working groups. And their working group 1 is power, working group 2 is fuels and chemicals, working group 3 is end user applications. So the power working group is focused on the energy storage, long duration hydrogen energy storage initiative, hydrogen for power generation, including methane pyrolysis, and then the offshore wind portion of the wind to hydrogen to ammonia initiative. And I'm sure a lot of work has been done in some of these areas, and we want to make sure that we are able to leverage and include any and all knowledge, expertise, and work that has been accomplished in those areas. Group 2 is focused on fuels and chemicals, the production of ammonia for export, for fertilizer, for marine fuel, and then the potential to produce sustainable aviation fuel in Puerto Rico. And then that also could be used not only on island, but could be part of an export strategy to the Caribbean region for sustainable aviation fuel. And then finally, group 3, the end user applications. We're looking at the ones we spoke about earlier: backup power for critical facilities, hydrogen for microgrids, and then finally the hydrogen transportation application for heavy vehicles is included in group 3. The working group meeting dates. This is the last slide of today's presentation. We are having the working groups meet 3 times over a 2-month period. The meeting location will be in San Juan. The meetings are scheduled to start at 9 o'clock in the morning and have a 3-hour window if needed each time. And the matrix of meeting dates and times is presented below. Working group 1, July 9, July 30, August 20. Working group 2, July 10, July 31, August 21. Working group 3, July 11, August 1, and August 22nd. So thank you for bearing with me on my We used to call this drinking from a fire hydrant. So a lot of information to absorb, but we thought it would be important to provide a sense, a taste of what it is we're up to as this process moves forward. And we welcome any comments or input at this time. But again, we are encouraging participation in our working groups. And it's a very important part of the success of this project. And we just really want to emphasize the importance of your participation in the working groups if you're available, or if there are other delegates that you might consider including in the working group meetings. Edgardo, is that any perspectives on your part in terms of the working group process as we go forward and the results of last year's study?
Not at this moment. I just wanna everybody to know that the meetings are gonna be here at the Puerto Rico Energy Bureau on the 8th floor. Maybe by next week we can send the details and everything, but it's gonna be here at the 8th floor in the Energy Bureau in World Plaza building at Torrey.
Edgardo, thank you for that update. We will distribute that information perhaps today. I think that's a very important to help people get that in their schedule.
Right.
Any other questions or perspectives? And again, we are open. The importance is that we rely on the stakeholders to let us know, to turn left, to turn right, to go straight. So any questions you might have, we welcome those both today or anytime you'd like to contact us.
Brad and Edgardo, thank you very much for having me here. This is Christian Worley from GRC Technologies. I have a question just regarding the organization. Would it be possible that all the participants that will be in person could have maybe a 3 or 4 minutes slot to present themselves and just make a 2-pager presentation of their company they represent and what they can offer?
Yes, I think, Christian, certainly we want to make sure that people are introductions are provided, and we'll definitely consider that. You know how to reach me, so if you could just pencil me that would be great.
Yeah, I send you just a sampler for what I have in mind. I have been going through a same like a process down in Brazil, and that was very interesting how they did that. So that just everybody knows each other within three or 4 minutes.
Yeah. Well, these are also small group meetings, and most everybody will probably know each other already, Kristen. So maybe you will need more of an introduction.
Okay.
Right.
Okay. Well, thank you.
Right.
Thank you.
Okay. Anyone else today? Please feel free to speak up.
Hi, this is Brenda Perez from Public Buildings Authority. Thank you for the excellent presentation. I want to ask if we can have access to the presentation in order to review the notes and all the information discussed today.
Yes, Brenda, and could you, if it's okay, could you put your name in the chat so we have the spelling correct and can find your email?
Yes, sure. Thank you.
Yeah. This is an invitation only meeting, so presumably we have everybody's contact information, but that may not necessarily be the case. Absolutely. So we just want to make sure, Brenda, so appreciate that.
Brett, I want to make a point that to the whole team here present, this is Jorge Rodriguez. That,
Speak up
if you-
a little bit, Jorge. Speak
Yeah.
up.
If there is anyone in the group here that may understand there is another potential person or organization that should be participating in this, please send us the name and the email, and we will forward the invitation.
It's a great point by Jorge. We have a few, we have a full slate of participants for working group 1, and working groups 2 and 3. We have our target is 9 participants, and we have 9 each for groups 2 and 3. So we need a few more potential participants for groups 2 and 3 based on recent assessment. So thank you, Jorge. That's exactly correct.
Yes, good morning. Let me introduce myself. My name is Israel Esparra. I work with Lord Construction Group. We appreciate your invitation to be part of this team. So I also include my email in the chat if it's possible to receive a copy of the presentation. It looks very interesting to us to get through that information.
Excellent. Israel, thank you.
Israel, any question you may have, just give me a call, and I can clarify for you, or even we can grab on the phone if required.
Yes, I will have a meeting after this one, but I will call you maybe during the day. Thanks, Jorge.
Yeah, thank you for your participation, Israel. And Jorge, I think we have Israel's contact information, correct?
Yes, we have it. I have it.
Yep, exactly. Exactly. Very good. Okay, I think unless anyone else has any input today, I think we're okay, but to move on, no need to use people's time. But any last comments or input today?
None on my side.
Excellent.
Thank you for the invitation. Carlos Velasquez from Interstate Renewable Energy Council.
Carlos, if you have any doubt, give me a call. Okay.
Well, yeah, it's I guess so. Let me add just 15 seconds. Based on the experience of how solar energy was introduced to Puerto Rico, back in 2005 to 2010. The first 5 years were really an effort about educating the public and the end user, and as you know, and more about education and certainly less about sales, right? And as you know, Puerto Rico, has a very high acceptance rate of solar and storage. I think because of that effort. So there's probably a knowledge gap about hydrogen. So I think when it comes to the barriers to the technology and to the implementation plan. I would imagine that a lot of the effort is going to have to be around the issue of education. So, yeah, I'll stop there.
That's a very good point. In fact, this meeting today is one small part of that process, but I think we'd welcome your input on how that could best be achieved. Certainly, and that's an absolutely key or very strongly illustrative of why we're engaged in this process, which is what's a potential barrier to success. Well, you just identified one, which is lack of understanding and appreciation for what these technologies are about and the importance of educating and informing. stakeholders on that. So thank you. That's an example of why we're doing the stakeholder process in the working groups. Was that Carlos or who was that?
Yes, sir. From
Okay, great.
Interstate Renewable Energy Council.
Yeah. Great. Okay, everyone. Edgardo, I think we're all set today. Is that true?
Yes. At least for me, I think that for today, we are ready.
Excellent.
And thank you everyone for being here.
Thank you. Bye. Thank you.
Thanks, everyone.
Thank you.
Bye.
Thank
Bye.
you.
Yeah,
Bye.
everyone.
Bye.
Thank you.